So welcome back everyone. Once again, this is Kevin from CSMI in Australia. Today, going to share with you some info on pumps. This question was asked by Nathan in the United States. And Nathan, if you're watching, this video is for you. What is the best pump and what are the different kinds of pumps? So basically, there's two kinds of pumps in terms of pumping medium. You have the centrifugal and then you have a positive displacement. So what you see up here, all these pumps are what we call positive displacement, which means whatever goes inside the pump through the system must return back through the tank. If not, the pump will just keep pushing, and liquids are not compressible, gases are. So the line will burst, or the weakest link in the system will give way and oil will spill out. So I'll repeat, gases are compressible, liquids are not. So any volume of liquid that goes into your pump, when you're creating an operation, that liquid must return back to the tank. If it doesn't, your line will fail. So if your excavator is bursting lines, it's quite simple. The volume of oil that's coming out of the pump isn't returning back to the tank. Maybe your servo is not in the right position, it's not traveling enough to open the valve, and hence that line is bursting. Or you don't have a relief valve and the volume of liquid sent out by the pump is not returning back to the tank. That's the only reason why it's bursting. So check your valve block, check your return lines, make sure the oil's coming back. If it's bursting only in one circuit, then check the centralization of the servo to make that it's traveling equally on both sides of the center position, so you got the volume of oil coming back and then you won't have a burst line. Second reason is, which I highly doubt, is the volume of the pump is so high that the system can't accommodate that. That's generally not the case unless you put a super duper heavy duty big volume pump, and none of these do that for the system that we use, right? So 1200 milliliter is what we use. Now, the two kinds of pumps is centrifugal or positive displacement. What's the difference? I just explained. Positive displacement, whatever goes out of the pump must return back into the system. If not, the weakest link in the system will burst. Centrifugal pump, you just have an impeller. The impeller will keep rotating inside the volute, and then what will happen is, this is not a centrifugal, but I'm just showing that the housing is actually called a volute. The impeller will just rotate. So even if you shut the discharge valve, it doesn't make any difference. If you ran the pump for a very long time, the volute or the body will get hot. None of the pumps or hydraulic pumps are generally all gear-driven pumps or positive displacement pumps, right? So they're not centrifugal. Generally, you use centrifugal when you're using liquids like water or any other thing where you need a lot of volume and you don't need a high pressure. If you need high pressure and low volume, then you will always use a geared pump, because geared pumps are designed for high pressure. And the reason being, they're very precise, they're machined completely, they're all gears inside, and the clearance between the gear and the actual housing of the volute governs the volume of oil that's going to travel through it. Now, as you go into cranes have hydraulic pumps. They're even more precise because there's no losses. So if your pump is aging over time, you will see losses, is because the clearance between the gears, the housing, and the gear teeth will actually wear out, which allows a little bit of liquid to flow back, and hence the pump has lost its efficiency. Okay, let's go further. There's a lot more than this pump curves and all that kind of stuff, the good stuff. I mean, we don't need that. It's pretty high-tech. It's only required, the head pressure, suction pressure, all that kind of stuff, discharge pressure or discharge head. That only comes if you're more high-tech, into more pumps and using pumping systems. For our application, we won't be discussing any of those. Or the pump draw head is how much a pump can draw from the depth of where it's located, or how much it can pump uphill going upwards based on atmospheric pressure. So we'll just stick to the basics. That's all we're doing in RC. So the next thing is the motors. So this is a brushed pump or a brushed motor. I know some of you know all this, but this video is also for the people who are just getting into it. So just bear with me. If you know all this stuff, you can just forward it if it doesn't interest you. The brushed motors have 2 wires. The brushless has 3 wires. It's got to do with a cycle of 360, the frequency or the hertz of how the motor runs. And brushed gives you more torque, because the firing cycle is 120 degrees and each wire is 120 degrees apart. 120 into 3 gives you 360. Here you have 180, so you have only 2 firing cycles, and hence it's in the brush wire you have only 2, and hence the torque is less in the brush compared to a brushless. You can go into more depth and understand turns and how much of torque the turns gives you, or the RPMs, or there's different videos. I'm not going to go into that for this one. So this is just based on pumps. Now, what pump do we use? Now, if you're using a hydraulic crane or a simple application, generally these brush pumps are pretty good because you don't need a lot of torque, you don't need a lot of pressure. It's just simple volume. They got a built-in tank. It's going to do the purpose. These actually come from Germany. And these are pretty good pumps. Now, if you want volume and you want pressure, then you want to look into these kind of pumps because they will give you 1,200 mil per minute, which is substantial for a big excavator, and they'll give you sufficient pressure. The next thing you want to consider is size. As you can see, there's a difference in size over here. You can see this motor on my left hand with the pressure gauge has a bigger motor compared to the one on the right. The reason being, this motor is putting out the same torque, has a smaller motor because it has a reduction drive in between, and that's where it's getting its power. You don't need a bigger motor. Advantages when you have a reduction drive, you can put a small motor, consume less battery, and you're going to get the same power. Whereas you use a bigger motor, you don't have a reduction, so it's going to take a little bit of more power from your battery. This pump is actually made in Italy. This one's made in Germany. And the difference is you're getting pretty much what this pump does. In this pump, you've got an integrated pressure relief valve built into it. You do have a pressure gauge to tell you the pressure. It does a pretty good job. We're using both of these in different excavators. All pumps will need a speed controller, and generally they all operate on 12 volt. Some of them do operate on 7.4. The next thing you want to consider after you've considered the tank and brush and brushless is the mounting and the input and the output of the pump, where you're going to position it, how you're going to mount it, what's going to be your suction, what's going to be your discharge. Are the suction and discharge put opposite each other? Are they on the same side? Generally, for all gear pumps, they'll generally be on the opposite side because it has to flow through, and you got 2 sets of gears, one top of the other, and the fluid is coming on the outside. So in this case, you can see it's at 12 and 6. In this case, you can see it's at 9 and 3 o'clock, right? But if I reposition it this way, it then becomes 12 and 6. So as you can see, it's generally on the opposite side of each other because that's how general gear pumps are positioned, because of the axis of the 2 gears directly on one on top of the other. This one is slightly different. The way they have designed it is the oil goes from the center into the volute, and then it's pumped on the top outside, and then there's a return line that goes back into the tank. Slightly different construction, and you do have a relief valve to adjust the pressure. Pretty good for about 10 to 15 bar. These things can go much more higher, 35, 40 bar, but then there's a limitation, is the pump body will actually manage the pressure, but it's the motor that doesn't have the torque to turn the pressure more, because you're having resistance in the system, because the system is able to handle maybe 60, 70 bar, so it's not going to burst. But the pump or the motor doesn't have the power to turn the shaft to push the oil at a higher pressure. So that's the limitation. But any excavator, if you're using more than 25 bar, it's not bringing you any value anyway, because it's just going to be lost because the machine isn't heavy enough to actually break the ground force or penetrate into the ground. The tracks will just lift. So there is no value using a very, very high pressured pump. What you need more than pressure is volume, because that will push more volume into the cylinders, and your cylinders will move much more quicker and faster. So that's where we're going to stop. Just a very basic video on pumps. If you have any questions, email us info@csmi.com.au. There will be a link which I will add in the bottom of the description to some of these pumps that you can buy from our website. Flick us an email or leave your question in the comment section below, and we'll get back to you. So as usual, thank you for watching, and we'll see you on the next video.